record. Yeah, broken line graphs. We're just on lesson 1.1. So I wanted to save you guys a bunch of writing. So I want to save you a bunch of writing. I just threw all this stuff on there. But so what a broken line graph is just like what we showed up here, like with the average temperature per month. We use points that are joined by line segments, which basically means that we go from one point to the next point. So I would go from January to February, and I would just draw a line that connects those 2 months. And then I draw a new line that connects February to March, and then March to April, and then April to May, and so on and so forth. So we use a graph that just looks at the points and draws lines between the points. And so using this, what we do is we display, it's called sets of data. We'll talk about the rest of this stuff here. But the really big thing we kind of want to focus on here is, am I sharing? Yes, I am. The big thing we want to focus on here is that the way we adjust our graph, the way we set it up, specifically the scale and the size of it, influences the way we look at that data. And we will see examples of that. There are ways that you can trick people into coming to a conclusion about your graph, about your data, based on how you do it. Advertisers use it all the time. So when we can change things in our graph to look at, to like change people's perspective of it. And so I'll be showing you some examples specifically about politics right now. Like right now in Canada, politics are heating up, right? Like we're going to be into an election next year. A lot of people are not fans of Justin Trudeau right now, and he is getting grilled because big two issues right now are the cost of living and inflation, right? And so there's lots of people who are making attack ads of it, and sometimes they manipulate the data of those ads to make it look worse than it is. And it's not great, but they make it look worse. So over here, you can just kind of see I've created a little bit of a checklist for when you're drawing a graph, like just some things to kind of keep note of here, which is we want to label it. This is stuff we've done before. We want to choose the variables to display on these are the axes. That's this thing here. It's just plural version. We want to look at the scale of them. And I am live streaming, by the way, if your eyes aren't too good. We want to decide on the scale of it. So that was what we had done like before. And then we're going to look at the independent variable and dependent variable. Oh, those are all things that we kind of looked at on Wednesday. So let's kind of jump into this here. So you can see an example here, right? So this graph here shows the average snowfall in Regina by the month. And so what's this graph actually showing here? I'll just zoom in a little bit. Well, it's showing on the left is I can see how much snow we get per month. And on the bottom, I can just see the months. And this kind of makes sense, right? Oh, we're starting in January. That's usually like one of the coldest months, the winter month. We can see we got lots of snow. And well, sometimes we get that. Last year we had a really bad snowstorm here in yeah, I don't know. Saskatchewan's weird. It's like we have 4 winters. It's so annoying. Yeah, so like they probably had their first winter here, their second winter, their third winter, and then their fourth winter, right? Just how it goes. Right? The places we live. But yeah, this graph makes sense, right? Oh, it's like, oh, it's the middle of the summer months. Of course it's not going to snow in July, right? It did that one year actually, but most of the times it doesn't. But so this is a graph, right? So one of our skills is we're going to be looking at how to read graphs and how to interpret it. And so when we're looking at this graph, so which is the month that had the highest average snowfall? December, right? And then how much snowfall did you get from that? Yeah, so I'm just looking at my axes. So I take my point, I go down. It's like, oh yeah, it's December. And I can see if I go all the way to the right, I can see, oh, I got 21 centimeters. So all you have to say is December, 21 centimeters. You could make a statement if you wanted. You could make a full sentence out of that. I'm not going to like penalize you guys on that. I'm not going to expect to see the average, the month with the highest snowfall was December and they got 21 centimeters of snow. This is fine. Like, that's fine. I know what you're talking about if you write that down. And again, what are the 3 months that there was no snowfall? Yeah, June, July, and August, right? We look at our x-axis here, which shows our months, and we just see that, oh, we have 3 points here that are on that 0 mark. So it's just reading the graph is what we're kind of doing here. So there's June, July, and August. Sometimes, though, they kind of throw some curveballs, which is when we really need to think about what the question's asking. And sorry, at some point I will get a phone call. I do need to take that. I haven't had water in my kitchen for 6 months or 6 weeks, so that's the plumber. And so during what month is the average snowfall twice as much as the average October snowfall? So it's a weirdly worded question. We're going to see that sometimes. So what do we have to look at here in order to, like, we'll figure this out? Well, we have to know how much snowfall fell in October then, right? And I know in October, I can see that I got, yeah, it looks like 7 centimeters. So if I'm looking for approximately twice that, well, which months would those be? Well, November and February, probably. Oh, sorry? The average? Oh, so there's actually 2 of them here, right? So, okay, October I got, looks like about 7 centimeters. What's a round double 7? Well, 14. I can see I got 2 months here that were right on there, both February and November. So you can have more than one answer. And again, you don't need to write a lot. That's fine. That communicates what we need, right? Again, I'm not going to like penalize you guys if you don't put a full, proper English complete sentence there. Put down the information and just make sure, make sure it makes sense. Don't have like February like all the way up here and then 14 centimeter down here. That doesn't make much sense to me, but just make sure it's connected and you're good to go. Cool. So we're able to look at a graph and we're able to analyze some of the information. So one of the skills is reading graphs, analyzing it, and interpreting what it means. The other skill we're looking at is actually creating these graphs. And so we're actually gonna make a broken line graph here. Can I do this? No. Okay. So if you're looking here, so first off, all this stuff right here. So this is a table. Specifically, this is a data set. It's a set of data. Oh, mine doesn't have, yours guys has a graph here, right?
No. Why?
Oh, I see. I printed out the wrong document. Okay. Okay, that's all right. We'll figure that out. You will need rulers then, and if you do not have a ruler, I have some. Who needs a ruler? Sorry about that. I meant to print that off for you. On Monday, you will have the right one. Anyone else need a ruler? Yeah. Oh, no. Okay.
So what we're gonna do is, we're just gonna kind of make two really big straight lines, using a lot of this space. Leave a little bit of white space here, you know, just put like your ruler there, and just make a nice long line. Make a nice long line, leave some white space there, it is important, I'll go make one on here as well.
Yeah, sorry about that, guys. Here, so I'm just making one. So I've used up most of my space with this graph. Not all of it. We want a little bit of white space here because we're going to be writing stuff in these columns, right? So you want to leave some space. Very rarely are we going to have to do this. This is just because I goofed up, guys. Most of the time you're going to have, maybe I can just,
Like,
yeah. Yeah, most of the time you'll have something like this. But in this specific case, we might have to freehand it a little bit. Okay. So what are we going to do? It wants us to graph this in a broken line graph. So I'm just going to quickly go up to my steps for success here for graphs, and I'm just going to follow them. So I want to label the title of the graph, the horizontal axis, and the vertical axis. So the title of this graph is, it tells me, company's net profit. So I'm just going to write that right at the very, very top. Company's net profit. You can put the year if you want. And next I need to label my horizontal axis, which is my X1, right? This is always our X axis down here, this flat line. And then this other one here is going to be my Y axis. That is always the rules with that. X is on the bottom, Y is the one that goes up and down.
how do you distinguish which one to pick as your x-axis and your y-axis?
Good question. It's like, okay, I know this is my x-axis, but do I put years here or do I put the money? And so this is a decision we're always going to have to make, which is which is where we bring in these two things. Remember this independent and dependent variable we talked about on Friday? Like, just to give you an example here. And so if I want to know how much money I make over time, well, that's dependent on my salary and how many hours I work, right? So if I want to know how much money I earned, that would be dependent on, well, how much did you work and how much money do you make an hour? So that this would be an example of a dependent one. And the independent ones would just be, I can just say like, how much money would you earn if you made it, if you worked 100 hours, 10 hours, 5 hours? So a nice rule of thumb here, first off, is usually if you have a time, that is almost always going to be on your x-axis. If you're dealing with something that involves measuring time, that's usually on your x-axis. Now, does anyone think, is time here? Do we think this is our dependent or independent value? We'll find out, but I don't even need to know that, because usually, like, a good rule of thumb, there's only very few exceptions in here where, like, oh, I'm dealing with time, that's going to be my x-axis, which means my money is probably going to be my y. So usually how it works is money is usually on your y-axis and time is usually on your x-axis. So our goal of this graph, don't write this. Our goal of this graph is we're probably going to get something that kind of looks like this, right? We've all seen these charts in like movies and stuff like that, where it goes up and down, up and down, up and down. It won't be this exaggerated, but this is just typically what we're going to see. So I've done my first step. I have labeled my graph. I'm just going to put that in here. So I'm just going to put year and money. I'm going to put in thousands and make this smaller. Just going to make this a little bit smaller here. Leave myself some space. Okay, so let's go to our next step here. What I need to do now is I need to decide on the variables to display in the axes. I've done that. I've already established, yeah, I want time to be X and I want money to be Y. So check, I've done that. Check, I've done that. Now I need to figure out the scale of it. And to give you an idea, when I talk about the scale, I mean that I can see here, how many years do I have? Well, it goes up by ones, but how many years, how many data points do I need to showcase? 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A lot of people might just go 9. No, you have 10 things we want to try and showcase here, right? Which means what I need to do is I need to be able to put all 10 of those things on here. Now here's an issue. Don't do this yet. But what happens if I do this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. I put my 10 years on here. This is obviously an issue, right? They're spaced different spaces apart. These have different lengths between one year to the other. And distance on the line means that it's not uniform. It needs to be the same. So I need to have the same distance between everything while also being able to fit all this, trying to use up as much of this space as possible. So what you're probably going to want to do,
Normally this is done for you. What I would recommend you guys do is actually take your rulers, measure out how long your line is. And then just like divide it by 10, because there's 10 data points, right? So like how long is someone's line for you? 15 centimeters. So maybe go up by so maybe every centimeter go up 1 year, for example. Or you can go every 1.5, that's fine too, but try and use a nice easy number. Usually ones, 1.5s, 2s, those are easier numbers than like a 1.7, right? We like 5s and 10s, it's easier.
oh, I'll get that right away. 1, 2, 3. So one thing you can do as well, it's okay if you didn't do it this time, but one thing to make note of is this is still a data point here, right? I can still use this as one. Like this at the origin, this is called the origin, right? That's 0, 0. I can still use that as a data point. So what I'm going to do is I'm going to now put my years in here. So 2000, I'm just going to say 0, 0, right? Just for the sake of space. You could put 2000 if you want, but it's going to be a little cramped. I'm just going to go up for the years for each of these points. So I've now marked my time in years. I have put a proper scale in there, which means I have the right amount of distance between these points, but they're also going to fit. Now, what do you think my next step's probably going to be?
Do the same thing.
Do the same thing for the money side. Absolutely correct. So what do I need? So what's the biggest number I need to go up to on the money side? 65. 65. I need to go up to at least 65. Which means I'm probably going to start at 0 down here. I'm probably going to start at $0, but at the very, very top, I'm going to need to have 65. And then just like before, I can't just have a bunch of like data points like that, right? It needs to be properly spaced. They need to be measuring the same amount of money. So I'm going to go up by, I'm going to go up by 5 or maybe by 10 is what I'm going to do. I'm gonna work my way from the bottom up. Go the other way around. Sorry? Oh, sorry, I have bad ears. You could go up by tens, that would work. You go up by tens, by fives. Those would probably be good numbers to go up by. I'm personally gonna go up by tens is what I'm gonna do. And I know I'm probably on the right track if by the halfway point of my graph, I'm about halfway there with the amount of money that I know I need to end up at, which is 65. 50, 60, and I'll go 70. Perfect. And again, you're all going to have different looking graphs here. I'm not using up all of my space here, and that's okay. As long as you're using up most of your space. That'll work. Using up most of your space, you're good to go. So honestly, this is the hard part, which is actually setting up the graph. And it's usually going to be easier if I give you a printed out version of it, but oops. So that is our next step. You're right. So we are going to graph it. So I'm just waiting until everyone's finished labeling their stuff. So the final step, which is exactly what we said, is I just need to graph. I just need to graph it. How do I graph it? Like, what do I actually do? What's the process? Sorry. Well, so I have to put the lines between the points. So what I need to do is I need to put the points and then draw the lines. Yes. So by points, I mean, I have to look at my data set up here and I can be like, okay, in the year 2000, how much money did this company make? 5,000. So I just go to my graph and I'm like, okay, in the year 2000, they made 5 grand. I'm just going to put a little dot there and that's it. Put all your dots, then draw your lines. So in the year 2000, I made 5 grand. In the year 2001, I made 15. In the year 2002, I made 18. You're going to be eyeballing it a little bit. It's not going to be perfect. If we wanted a perfect, like to the millimeter, correctly labeled graph, we would do it on a computer. We're doing a freehand graph. That's okay. There's going to be some small errors in it. Maybe we accidentally put this at 17.5 thousand instead of 18,000. That's okay. We're just doing our best with what we can. It's harder when we were doing it by hand. So I'm just going to put in all my data points. So 2003, I made 35 grand. It can do that. Companies lose money. 2004 was 40 grand. Five. So I'll give you just a second there. Okay. So now I've plotted my points. Now all I do is I'm just gonna take my ruler.
We could even do a freehand, honestly, like if they're close enough. And I'm just gonna go from points to points to points to points to points. I'm just gonna connect them.
And you should get a graph that is gonna kind of resemble. Again, mine's always gonna be worse because I don't have a ruler how I do this. I don't have the option for straight lines. But you should get a graph that kind of looks like this. Yeah, I'll give you a second here just to graph it. Here, we'll come take a look.
Oh, 2000 and. I think you missed the points. Oh, yeah, so I think what happened was. You went from, 5,000 to 15,000, 18,000, 35, and you're supposed to go up to 45. Yeah. I think that was it. Oh, and so you usually go to the next one, so she go like that. Yeah,
Okay.
yeah, fill it in and we go left, right?
I messed up, I was like, where did you get that line?
Oh, yeah, it's really easy, right? Like, it's really easy to miss a data point. Everyone does it, I do it, it happens.
But you should get a graph that, again, everyone's graph is gonna look slightly different. Because we all use different scales. Maybe all of our lines were different lengths. You know, again, we're doing this freehand. We're gonna have just human errors in there. But generally speaking, all of our graphs, you know, once we correct those errors, as long as we plotted all the points, they kind of follow this, right? And so now what we want to know is we want to know what the general trend is happening in this data. So what's the trend in this company's profits over time? As we read our graph, we read from left to right, right? Is this company making money? Yeah, for the most part, the trend of this is that they're making money. When I talk about trend, you know, it's just a common pattern. What's the common pattern as we go from October to November? Temperature. It gets colder. But like, have we seen the weather this week? Is it normally this warm out in the middle of November? No. So sometimes there's also exceptions with this. So the general trend of this is that they're making money. But there is an exception with this though. Specifically, it's this point here, right? Yeah, it dropped. So so what's the general trend of this data? Sorry? Yeah, if we're looking at like the slope of this, like the general trend of this graph is that or the general trend of the data is that the company is more profitable over time. They make more money over time. But there is an exception. And the exception is, except for 2007. There's this little one here too, but that's basically the same amount. So we're looking for those really big differences. Okay. Cool. Now, you might have noticed, if I scroll up a little bit, there's two things on here I haven't talked about yet. Any guesses? These ones here, yeah, interpolate and extrapolate. So we're going to quickly just look at what those are. So first off, interpolate is when we estimate, we take an educated guess at what a number is going to be between two values. And so the next question here on page 5 is going to give you that exact thing. So what we see here is we see a graph that shows the height of a bean plant over time. Like what's going to happen when you plant a seed? The plant's going to grow typically bigger and bigger and bigger, right? If anyone's here has ever had a garden, yeah, you plant a seed and boof, it comes up. Unless you're like me and you just like kill every plant you touch. So we have a graph here that shows the growth rate of a bean plant that was planted in a garden. So what we can see here, though, if you look at week 3 and 4, if you look at this little section right here, he didn't mark week 3. He forgot. So interpolating is, okay, I'm trying to guess. I need to try and guess where in week 3 I think his plant is probably at. So I have 2 data points. I need to take a guess, an educated guess, where I think that is. We're interpolating where we think week 3 should be. Like, how high do we think it was?
At week 3,
Yeah.
maybe like 12 centimeters.
Yeah, like I can just look at my graph here. I can look like, yeah, maybe about 11 or 12 centimeters. That seems about right. We don't know for sure. We're just taking an educated guess. So that's what interpolation is we're taking an educated guess based on what we know between 2 value points. So I'm going to maybe say, I think it was this. So I've now interpolated that. I think it was 11 or 12 centimeters. Now, that's what interpolate is, right? Where, okay, I know what it was before. I know what it was after. Now I'm guessing what's in the middle. Extrapolate, which is our final term here, is where we're going to guess what that is beyond the range of values we have. And that's the fancy way of saying is, I can see that this plant goes up until week 11, right? I can see that this bean plant went up until week 11. My question for you is, maybe I got sick, I didn't harvest it on week 11. How tall do you think it would be in week 12? Probably about the same, yeah. So we're just guessing after or before. So interpolate is going between 2 values. Extrapolate is going after it, yes. Yeah, it probably is going to go up like slightly technically. Like it's probably still growing, just not a lot. But generally speaking, it looks like it's going to be about 39 or so centimeters, right? 38, 39. So interpolate, guess between two figures. Extrapolate is guess after the data set, if that's what makes sense. And you can think about it this way. Interpolate is inside, in. The first 2 letters should be your key there. Interpolate, inside. Extrapolate, the exterior, the outside part of it. Where's my stuff? Where's my stuff? Where's my stuff? Cool. So the final thing we want to do here is we want to write a statement that describes the trends. And so like, let's just look at this. So in this graph here, what's happened in the first few weeks with the growth? Let's look at these first few weeks, because we can see here, I'll use red, that after this, what changes? After week 3 or after week 4, what changes to the the data set here. Yeah, yeah. So we can see that, okay, well, I think in the first, what is that, the first like 3 weeks, 4 weeks? So in weeks 1 to 3, in weeks 1 to 3, it it grows slowly. But then exactly what you said, Ravon, in weeks 4 to, looks like, what is that, 6? Weeks 4 to 6, I think. It growed, it had a growth spurt. It didn't grow slowly, it grew slowly. Right, so we're writing a statement that just describes it. We're not adding like crazy details. We're not writing full sentences. That's okay. And then after that, what happened after week 6? Well, or I'm sorry, after week 5. This is week 5. And then after that, well, week 5 to 11, it grew very slowly. Like very slowly, right? At that point, it was only growing a tiny little bit. That's fine enough, right? It's just writing down like what if we're thinking out loud when we look at a graph, it's just writing down those thoughts. If you can't see, I do have it like live on the Zoom as well. So pretty close to cutting you guys loose. The last thing I kind of want to talk about though is if you go to the next page, what is different about this than the last graph that we drew? There's more numbers. There's 2 things. I technically have 2 different data sets here. I'm looking at the house prices of Regina and Vancouver now. And so like, how could I like display this? I could use 2 different lines with 2 different colors. Absolutely. I can do that. So if we talk about like, well, what am I going to put on my axes, right? This is my x-axis. This is my y-axis. Yeah, you can make one line more bold. You can use dashes. There's tons of different ways to show it off. Absolutely. So, just because there's more than 2 things here now. Well, there's 2 cities, there's years, and there's money. Like, what do I do? What do I put what? Well, I see years. I have years here. What is years usually going to be? It's usually going to be the x-axis, right? Years is usually your x-axis. What's going to be my y-axis? Money. My y-axis isn't going to be Regina or Vancouver. Those are going to be my data sets, my points. But what will be my y-axis is money. Specifically, though, it's going to suck having to write all these zeros after each time, right? Why don't I say money in hundreds of thousands of dollars? So when I say, oh, make that smaller. Admit. So maybe now if I put like a 1 here, this means $100,000. Or you could even just put, actually I'm gonna put thousands and thousands. So maybe if I put 100 here, it's $100,000. If I put 200 here, it's 200,000, so on and so forth, right? So I'm going to let you guys try and do both of these. I'm going to personally use 2 different colors, but if you don't have 2 different colors, You could do like a dashed line. If you're looking up here, you could do that and a solid line. That would work. You could do a bolded line and a dashed line. Or actually, yeah, sure.
Maybe like for bold, like, if you use like a pen.
You could use pen and pencil. Yep. So I'll let you guys start making that graph there. I'll give you a couple minutes before I come around. If you're not sure what to do, please let me know. Oh, let me pause this. All right, so we're almost done. What you should eventually have is you should eventually have a graph that kind of looks like this, something like this. Again, everyone's is going to look a little bit different. One of the common things that we saw is if we started at 2000, you can see here down here, I started at 2006, right? If you started at 2005, which is okay to do, your first data point then would be a little bit into the graph. That's okay. But you do not want to go like that, right? Houses were not free. We want to only draw the lines between the points. We don't have a point at $0, so we wouldn't draw that. That's a really common thing. There's a reason I choose the houses first, is because wouldn't it be nice if houses were free last year? Like they're not. So you should have two graphs that look like this. The one thing I will also say is you're going to notice I have put some labels beside each line. It's important to know, not just by color, but I also know that, oh, that's my Vancouver line. That's my Regina line. It's helpful to put labels beside. Oh, so you did like a legend like this thing?
Yeah, or like I put Regina and Vancouver both at the top of the page, and then in brackets for Regina, I put the boundary line.
That would probably work too, yeah. I think that could probably work, yeah. Cool. So I have my information here. Now, I've chosen this data for a reason. One of them was to make sure, like, first off, we're not going to have any free houses. That's not a thing that happens. But the other thing I just want to make mention of here is, so first off, what are some conclusions we can make about this data?
House prices are rising.
House prices are rising. So that's one. House prices are rising. So that's one conclusion. And there should be one more thing we can kind of get from this.
Regina's cheaper than Vancouver.
Yeah, Vancouver is more expensive. Right? Those would generally be the two conclusions we could make from this, is that over time, the cost of houses is rising, and that Vancouver is a hell of a lot more expensive than Regina. So part of it's demand. So we have a lot of demand. There's not a lot of new houses being made. So there's more competition for those same houses. And then there's also inflation and stuff like that. And then like interest rates were non-existent for years. So like you could get a really expensive house and not really pay any interest on it. But basically there was 1,000 reasons for people to buy houses, and we weren't making enough houses to keep up with that. So it's like, if there's like only 10 PlayStations available and 1,000 people want it, you bet your ass I'm gonna like sell mine on Kijiji for $2,000. So those are my two conclusions I can make from this. But now one thing that's important to note, sometimes the data set is more reliable than the actual graph. Like this is technically telling the same story between the graph and the data set up here. But one thing that's a little bit harder to tell from this graph is it's really hard to tell the difference between these two figures, isn't it? Like, like these two. It's like mine's not very expensive, but they're only $2,000 away. This graph is up to $700,000. That might look like it's at the exact same place. So it's harder to see those differences, those small money differences over time. If the data set is really small.
Well, we can see it directly in here, we can see it perfectly in here, but again, looking at this, these almost look like they're in the exact same place, right? $230,000, $232,000 of the whole 700,000. It's very hard to tell the difference just looking at the graph. Looking at the graph, it's really easy to see, oh my god, Vancouver's way more expensive, oh, house prices are rising. It's easy to see that with the visual stuff, but it's hard to tell those really accurate, detailed differences just off the graph itself.
So they both serve different purposes, right? So what can we tell more readily? What can we tell easier? That Vancouver is way more expensive, right? And I have one more curveball for you. See if you can spot it. So I'll give you a second. So if you look at the graph on the next page, see if you can spot what's weird about it. Sorry?
It's 205s.
205s. Good guess. Kind of. That is one thing that's different about it. We're going up 6 months now at a time instead of 1 month or 1 year. So we've adjusted our scale of that. Mhm.
That one weird thing on the side, remember?
Yes. If you look right down here, this little thing. So you see it instantly goes from $0 to $500, but then this giant space here is only $50. This giant space over here is only 50. This giant space over here is only 50. So what did we do? We just kind of skipped the first $500. So this little thing right here means that it's not a perfect thing that goes from $0 to whatever the max amount is. I just went straight up to the $500 mark because it never goes below that. Because otherwise, what's going to happen with your graph if you didn't have that? It's going to look something like this. It's very harder. It's a lot harder to see the differences between these two. If I start at 0 and then this is 100, 200, 300, 400, 500, and like 600 and 700, it's very hard to see those differences. So all I did was I got rid of all of this stuff down here. I got rid of all of this stuff because I'm not going to put anything in there. So it lets me use the space of my graph more efficiently. And we use this little symbol over here, that little squiggly, to kind of show that, hey, I've done some stuff with this graph. So that's why it looks weird. Sorry. We could have went straight up to we could have skipped the first $120,000. Absolutely, we could have skipped the first 100,000 if we wanted to. So sometimes it's appropriate to use, and sometimes it's a little bit less appropriate, but it's just a tool we have. But so when you see that squiggly, that means that, hey, I've skipped a bunch of these numbers to make it easier to see. That's exactly it. Because remember, the scale always needs to be the same after that, right? Then it's always $50 per line, 50, 50, 50, 50. So if we're looking at this, so first off, what looks like happened to the price of sheet metal over time?
It dropped. Shot up and then down again.
Yeah, it looks like, I'm going to say demand has fluctuated is a fancy way of saying that. But overall, the price has dropped. Right? So demand has fluctuated over time, but the price has dropped is the ultimate conclusion. Metal is cheaper in 2009 than it was in 2005. Maybe demand was the right price, I guess, but so the next question here asks us two things. It's asking us two things. What is the scale and the starting point of the vertical axis? The starting point is 500. It is not 0. This little squiggly line tells me that I'm starting at 500. So it starts at $500. But what about the scale? What does that mean? What's the scale measuring?
Is that like how it's gonna-
Yeah, so it's going up $50 at a time. So the scale would be $50. So it's looking at the difference between your points here. So I can see that it's going up $50 at a time. And I know I'm looking at the dollar thing because it says the vertical axis, right? The one that's going up. Oh, I didn't give you guys that space either. Darn it. Like I said, tomorrow you will have all these little graphs I've put in here. Yours should be blank right now though, right?
Yeah.
Yeah, that's my bad, guys. So the only thing I'm going to want you guys to do is now try remaking this exact same graph. So now we're going to take a graph and we're going to make a graph from that graph. We no longer have a traditional data set, but we still have the points, right? I still know that in January of 2005, the cost of it looked like it was, I don't know, what is that, like 660? I'm taking a guess, right? I know that in July of 2005, it looks like it was about, I don't know, 540, just taking your best guess, right? So you still have the data points. We can still get this information from it. So what you're going to do is you're now going to draw this graph without this little thing. And we're going to see it how this looks, because a part of the goal that we have with this is we want to start to be able to look at graph manipulations. People can lead you to have different conclusions about information depending on how we present that information. So this is technically a manipulation right here. Maybe it's a good thing, maybe it's a bad thing. We're going to find out. So we're going to look at the graph as if we started at 0 and maybe we went up, 100, 200, 300, 400, 500, all the way up to $750.